If you guys look on Canvas and modules, there is an extra quiz review with the worked out solutions. Do it. It's not due, but if you want to look at something and say, hey, I need a little extra practice on this, or I'm kind of confused on this, that's fine. I have a softball meeting after school today, but if you want to come after it, maybe like 2:45, 2:50, if you have a question, come ask me. If you want to come tomorrow morning before 8 a.m., because I'm not in here at 8, you're welcome to come by and ask. So just come. I will have pencils for you tomorrow. You'll have the class period. There's 10 questions. You'll be fine. All right, so if we come to something that says simplify, right off the bat, on number 1, are you probably going to find the largest square root that goes into this? No. But where would be a good starting point? 112?
Yes.
Okay, I agree with you. I think that's a good starting point. 100 times 12. Dylan?
Why wouldn't you just do 400?
Some people don't see that right off the bat. So yeah, you can do 400. But if I have 100, what is the square root of 100? 10. And then I'm left with 12 underneath. And you guys get here and you're like, wait, I think I can break this down more. What can I break 12 into? 4 and 3. Okay, so then what is the square root of 4? 2. And then what do I do to the numbers on the outside? Multiply. So this becomes 20 square root of 3. If you saw the biggest perfect square, perfect. But if you didn't, you can still get there by just breaking down methodically. All right, coming to number 2, guys. Notice there is a binomial. There's 2 terms in the numerator. Those are stuck together. You can't just start crossing off random 3s just because. Last period, I had a few people that really were confused by this concept. So you have to understand that 4 is stuck with the positive 3 root 2. The 3 in the denominator that's in the square root has nothing to do with the 3 that is a coefficient in the numerator. What is the problem that you see here? There's a radical in the denominator. How do I fix that?
You multiply the top and bottom by a radical 3.
Perfect. We're going to rationalize. We're going to multiply the top and the bottom by radical 3. So I'm going to go ahead and deal with the denominator first. Square root of 3 times the square root of 3 is the square root of 9, which gives me what? Okay, the whole number 3. What did we want to happen? The radical to be out of the denominator? Mission accomplished. So now we just distribute. The square root of 3 times 4 is just 4 times the square root of 3. Then I have the square root of 3 times 3 root 2 becomes what? 3 square root of 6. So remember, inside a house, you can multiply, you can combine, and there you go.
I thought it would be like 9 square root. Would 3 over 4 become 9?
No, because there's a 1 on the outside here. So you multiply the numbers on the outside. 1 times 3 gives you 3. Then the numbers on the inside. So 2 times 3 gives you 6. Sometimes it's easy. It makes it a little easier to put the 1 to kind of see where numbers are outside of a radical and inside.
Do you simplify it?
There's nothing to simplify. I mean, in a sense, you could, Luna, you could say 4 square root of 3 over 3 plus the square root of 6. Was that what you were thinking? Okay, because, right, I have a monomial. We don't need to get into this right now, but we have a monomial in the denominator. So you can rewrite this fraction as 4 square root of 3 over 3 plus 3 square root of 6 over 3. And then you can simplify there. But there's no need to do that right now. There's no need. But no, can you like cross off this 3 and this one? No, because that 3 is attached to the 4 radical 3. Good question. All right. Where does the problem lie here? Okay, guys, let me caution you. You cannot just cross these out. You cannot cross the 1s out. Remember, this is 1 plus and minus the square root of 3. The values are very different. 1 minus the square root of 3 is not the same thing as 1 plus the square root of 3. They're 2 different values in the numerator and the denominator. So I need to get that radical out of the denominator, but I can't just rationalize by radical 3 because it's a binomial. There's 2 things there. So what do I have to multiply the top and bottom by? 1 minus the square root of 3. You multiply by the conjugate of the denominator. Good, Luke. And what you do to the bottom, you do where? To the top. So I always use I deal with the denominator first just to make sure I have my signs right and my radicals cancel. So let's multiply. Let's FOIL. 1 times 1 is 1. 1 times negative root 3 is minus. If you want to put the 1 there, 1 root 3, it's fine. Then I have root 3 times 1, so it's plus 1 root 3. And then I have positive and a negative gives me minus the square root of 3 times 3 is 9. So as I go to simplify, I notice that a positive and a negative, 1 radical 3 cancels. And then what is the square root of 9? 3. So what am I left with my denominator? 1 minus 3 is negative 2. Uh-huh.
Could you unscribble it so like it puts in one of the numerator equation?
If I unscribble it, it'll go away. So let me just rewrite it. So I had 1 minus the square root of 3 plus the square root of 3 plus the square root of 9. So I scribbled this out because these two are opposites. They cancel each other out. There should be a minus, sorry.
Where'd you get the plus square root?
When you FOIL, 1 times negative root 3 is negative root 3. And then we're doing the denominator. So I always do the denominator first. I just said that because I want to make sure I have my signs right, and then I don't have to worry like, oh no, at the end I'm stuck with all these radicals in the denominator. I know right away, okay, I'm good. So now I can go ahead and finish. Let's FOIL the top. 1 times 1 is 1. 1 times negative root 3 is minus 1 square root of 3. Negative root 3 and 1 is minus 1 square root of 3. And negative root 3 and negative root 3 is positive the square root of 9. As we simplify here, guys, what is the square root of 9? 3. So can I add 1 plus 3 and give me 4? Good. And then I have a negative 1 radical 3 and another negative 1 radical 3. What does that give me? Negative 2 square root of 3. Yeah.
Where did the 4 come from?
1 plus 3.
Oh, okay.
You could divide that by 2.
You could, but you don't have to.
I feel like I should.
Excuse me?
I feel like I should.
Okay, then you can.
But would it make sense?
It would be correct either way. We're not asking you to simplify this rationalization on this quiz. Going forward, yes, but you could if you wanted to, but you don't have to.
How come when the radical 3 is by itself, you don't have to make it a negative, but when it's not by itself, you have to make it into a negative?
Okay, that's a good question. Why do you have to use the conjugate? Okay, the question was, how come when you have a denominator of like 1 plus the square root of 3, you can't just say, well, top and bottom square root of 3, right? Is that what you're saying? Yes? Now, the reason why is we're trying to eliminate the radical from the denominator, right? So if I multiply this, I get the square root of 3 plus the square root of 9, right? Which would give me the square root of 3 plus 3. So I still have a radical in my denominator. You have to multiply by the conjugate to get the radicals to disappear. That's why we have to do that. Okay? Yeah, whenever there's two things joined by a plus or minus sign, you always multiply by the conjugate. Whatever the middle sign is, you change it. All right, what about something like this? Talk to me about different ways you could solve this problem. There's not just one way. If I have a radical in the numerator and the radical in the denominator, we can just divide and simplify, correct? You could absolutely do that if you wanted to. What's another thing you could do? You could simplify the radical right away. Does the square root of 81 simplify real simple? Yeah, go ahead and redo that. I'm going to break up 27 into 9 and 3. And I'm going to go ahead and say the square root of 81 is 9. Simplify the numerator a little more. What is the square root of 9? So I have 3 root 3 over 9. Do I have coefficients on the outside that can simplify? Yes. 3 goes into 3 once. 3 goes into 9 how many times? 3 times. Can I simplify any more than that? No. Yes.
On the quiz, is it gonna matter if you simplify it like that?
Like if you left it as 3 root 3 over 9, you'd get a point or two off, yeah. All right, couple things you could do here. Should you just go ahead and multiply 66 times 44? No. All right, I'm going to write it out the long way so everybody can see every single step, but I understand you're going to skip steps along the way. But I'm going to say I can rewrite this as 3 times the square root of what? 11 times 6. Okay. Then I'm going to say 2 times the square root of what? 4 and 11. Okay. Now, is there a square root underneath the radical that I can go ahead and take out? Yes, the square root of 4 is 2. What do I do with these numbers on the outside? I multiply. So this becomes 3 square root of 11 times 6 times 4 square root of 11. Some of you already see this. Some of you don't. Let's think about this. You can multiply stuff on the outside of a radical, and you can multiply stuff on the inside of a radical, correct? So I'm going to say 3 times 4 is 12. And then I'm going to put all the stuff in the radical together. When you guys take out square roots, you're taking out pairs of numbers. Do you guys agree with me that 11 times 11 is 121? So what can I take out of this radical? I can take out an 11, and I multiply it out here. Some of you are sitting here going like, seriously, I have to multiply? Yes, you're going to have to write down on your paper tomorrow 12 times 11 if you don't know it in your head. And you're going to have to multiply it out. All the numbers are not going to be like 2 times 4.
What's 12 times 11 again?
132. But if you don't know that off the top of your head, write it down. It's better to write it down and get it right than to just do no work and say it's 122 because you forgot to add the carried 1 or something like that. All right, when we are talking about something like number 6, how are 5 and 6 different? Wait, question.
Why did we cancel, why did like the 11 stay, one of the 11 stay in the radical?
What's 11 times 11?
121.
What's the square root of 121? So we took the square root of out. When you have 2 of the same number underneath, you're taking out a pair.
Oh, okay.
What's the difference, guys, between 5 and 6? Luke, tell me. Yep. In 5, we're multiplying. So anything inside of houses we can multiply together, anything on the outside. It's not the same with addition and subtraction. When you are adding and subtracting, you have to have like terms. The radicals have to be the same. Variables have to be the same, that thing. So as I start off, I cannot combine these two right now. But I can simplify them both. What can I break 18 into? Okay, 6 times 3, but are either of those perfect squares? What else? 9 times 2, okay. Plus, what can I break 50 into? 25 times 2. So, let's keep going. What is the square root of 9? All right, what do I do to these numbers out here? So I have 12 square roots of 2. Plus, what is the square root of 25? 5. What do I do to these numbers out here? Multiply, so I have 10 square roots of 2. Can I now combine these two? Yes, if I have 12 of something and 10 of the exact same thing, I can put them together and get what? 22 square roots of 2. Good. If you are adding and subtracting, the first thing you should do is break down each radical independently into a perfect square and a non-perfect square. And 95% of the time, it'll work out pretty. The other time is one of those tricky ones when you go, oh, I can't simplify it anymore. Okay, look at the difference between, well, look at the difference between 7 and 8. Go. Look at the difference between 7 and 8. What are you doing in 7 and what are you doing in 8? 7 you're multiplying and in 8 you're subtracting. 2 different rules, guys. 2 different rules. After you distribute the exponents, there's 2 different things to do here. So in this case, this 2, remember, goes to everything inside. This 2 goes to everything inside. If you need to draw those little arrows, do that so you don't forget to distribute to the coefficients. So this is 4 squared, x squared, y squared. Agreed? And then I have times 3 squared x to the 4th y squared.
Because one exponent is multiplied in parentheses and multiplied by exponent outside, it's like basic multiplication.
Yep, power to a power, you multiply. So 4 squared is 16, x squared, y squared, times 3 squared is 9, x to the 4th, y squared. Now, since we are multiplying, multiply coefficients. What's 16 times 9? 144, good. We are multiplying, so you write the base one time. You rewrite the base one time and do what to the exponents? So 2 plus 4 is 6, good. Rewrite the base one time, w, and do what to the exponents? Add them. 2 plus 2 is 4. And that is it. Multiplying same bases. You rewrite the base, add the exponents. Yes, ma'am?
I thought that if they had the same exponent, like y squared times y squared, it stay the same.
If you're adding and subtracting.
Oh, okay.
In this case down here, we are subtracting these two. We are not multiplying them. So again, we're going to distribute the exponent to everything in both cases. So I have 3 squared x to the what? 4th, and y to the 4th, minus 2 to the 4th, x to the 4th, y to the 4th. Agreed? Okay, so simplify. 3 squared is, so I have 9x to the 4th, y to the 4th, minus 16x to the 4th, y to the 4th. Since we are subtracting, adding and subtracting, you have to have like terms. Are these two terms like terms? Yes, I have 9x to the 4th, y to the 4th, minus 16x to the 4th, y to the 4th. What's 9 minus 16? Negative 7, and then, like Luna just said, our variables will stay the same. If you were multiplying, you would rewrite the bases and add the exponents, but we are not. We're adding and subtracting, so the last names stay the same. Yeah.
Let's say the y, okay, the y and the 9, next to the 9, let's say it were like y to the,
Okay. So let's do an example.
let's say it was,
So it's like you had 9x to the 4th, y to the 3rd, minus 16x to the 4th, y to the 4th.
yeah,
Can I combine those two? No, that would be it. That's be as far as you can go.
so you wouldn't even be able to,
No, because the variable is this together. It's not just independently. I have x to the 4th and then a y to the 4th. That is the last name. If those are not exactly the same, you cannot combine. So here, you could not combine. Question? Yeah. Does that make sense? All right, move. You guys doing well? Really, 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 guys, really pay attention to these kinds of questions. These can be really simple, but they can also be very confusing. Yes?
I had a question that was like,
All right. Do I have any negative exponents attached to anything? Yes or no? Number 9. No. So rewrite this. What does this really say? 27 to the 1/3 power is what? The cube root of 27. Now ask yourself, what does that mean? What number times itself 3 times gives me 27? Your answer is 3. That's it. Don't complicate things if you don't need to. Do not complicate things if you don't need to. Look at number 10. Told you guys a little thing to help you. If you see a negative exponent, circle what has the negative exponent. Make sure it's not attached to anything else that you get confused with. Yeah.
So when the 4 is in parentheses, does that mean that like the -3 doesn't apply to the 4?
No, if it was like this,
Yeah.
it's just saying that the -3 applies to only that 4.
Oh.
But if it was like it, you'll see in a second. You'll see where negative outside of parenthesis versus inside of a parenthesis matters. So how can I rewrite this? Because I don't like negative exponents. We don't work with negative exponents. So how do I rewrite this? 1 over. Good. 1 over 4 to the 3rd. So now that becomes, what's 4 cubed? 64. Thank you. Again, we don't get extra points for being the first one done. Go back and check your work. 4 cubed is not 12. If someone said 4 cubed was 12, what did they do? They multiply instead of raising to a power. Just little stuff like that so you guys don't lose points. All right, what does 11 say? The cube root. Rewrite it so you can see it. It's the cube root of 1,000. What? Squared to the power of 2. What is the cubed root of 1,000? 10. And 10 squared is 100. Good. Now here is something, guys, this next one. Pay attention to this. This is over a 1, right? Do you see the negative exponent? Yes. So I'm going to remind you, when you see the negative exponent, circle what has the negative exponent. Why did I not include the negative sign? Because there's no parentheses. It does not tell me that the 81 is negative and I'm raising it to the negative 3/4 power. It's telling me to find 81 to the negative 3/4 and then multiply it by a negative 1 out in front. The difference would be like this if it said this. Do you guys see the difference? I would circle what has the negative exponent. Do you see how the parentheses tell you, hey, include the negative, the non-parentheses tell you not to. So just pay attention to that. This is not what it's saying. So I'm going to, you don't have to write it like this. I personally am just going to write a negative out here. Because what this means is my answer is going to be negative. That I'm not going to deal with anymore. I don't have to worry about it. How do I make this positive? I say 1 over 81 to the 3/4. And then we go about simplifying. This is negative, and I have the 4th root of 81 raised to the 3rd power. What is the 4th root of 81? 3. And 3 cubed is, yes. Does not matter where you put the negative at the end. Just make sure it's with the problem. Yep.
So I did it where you figured out the...
All right. You guys will for sure have something that looks like this. Do not try to do everything in your head. Some of you, not some of you, a lot of you asked me, I think it was like number 16 on your homework that one night when it was like 16 to the 1/4 and like the rules don't change, guys. Just because there's a lot of stuff to distribute to and all that, deal with it slowly. Take your time. You have plenty of time to finish the quiz tomorrow. Plenty of time. This too distributes to what? Everything. Draw the arrows and say, don't forget. Goes to everything in the numerator, everything in the denominator, and then deal with it. So I have 3. I'm going to write my 3 in parentheses. It's positive. Who cares? Just make sure you understand that. So I have 3 squared, x squared, y to the what? -4. Perfect. Then I have 4 squared, x to the -2. Y to the 4th. I personally don't like to deal with negative exponents. You guys can do this however you'd like. If you'd like to say -4 -4 and then do all that, that's fine. I personally like to say, I just want to move this where? To the numerator. And I want to move this where? To the denominator. I'm going to go ahead and do that first. It just makes things easier for me. So, what is 3 squared? 9. Okay. So I have x squared on top. And what else do I have on top? X squared. Good. On the bottom, what is 4 squared? 16. And then I have y to the 4th and y to the 4th. Just easier for me to see. That's the way I like to look at it. Can I simplify anything with 9 and 16? No, you can't. So now let's talk about, all right, when I have same bases, guys, we rewrite the base and do what? Add the exponent. So this becomes x to the 4th. Good. Same bases, I rewrite the base and do what? Add the exponents. This becomes y to the 8th. And then that's it. You have to do that.
Oh, no.
If you're multiplying, same bases, you rewrite the base, add the exponents.
For the second equation you made, why wouldn't it be 9? Why couldn't it be just?
Hold on.
Why did you replace the y with the x and the same for the bottom?
Because the exponents were negative, so I like to move all the exponents to where they're positive. You didn't have to though, Alec. You could have gone right here when you had x squared and then x to the negative 2. You could say, okay, the bases are the same, right? And you're dividing. So you could say x to the, you subtract exponents, 2 minus a negative 2. Which, what's 2 minus a negative 2?
That's 4.
Yep, so it's the same thing, right? I just don't like to deal with negative exponents.
Let's say for that one, you don't switch it and keep it like that. When you subtract it, where would you like to do it?
In the numerator.
For both of them?
No, if you kept it like that. So then look, then your y's, you rewrite the base, and then you subtract top minus bottom. So it'd be minus 4 minus 4 would give you y to the negative 8, right? Which would then put it in the denominator. That's why I think it's easier to move all of your negatives first. Then you don't have to deal with like, oh, where should I put it? You know what I mean? Like it's easier to say.
Let's say we do that, it always goes to the top. If we subtract it, and if we subtract it, add it.
No, not necessarily. If you had like y to the 2nd and y to the 7th, where is your exponent bigger? So that's where it's going to stay. Because think about it. When you subtract, you're going to say y to the 2 minus 7. So this becomes y to the negative 5th.
Oh, and then it's gonna go down.
Or you can also look at it as I have 2 y's on top. 3, 4, 5, 6. Why did I pick 7? So when they cross out, how many do you have and where are they left?
So
Sure.
what if I simplify and like put in the negative, like I flip the negatives and everything before I distribute the exponent, like the.
No, you have to distribute the exponent first.
So you can't do it like after you've already simplified.
No, you need to distribute that first, then do your moving. Yeah. Exponents first.